What we're going to take a look at today is solving trig equations when we have a calculator. So what we're going to go through and solve is 2 times tangent of theta plus 1 equals 0, given the condition that our angles have to be between 0 and 2 pi. So basically what that tells us is we're using angles that are going to be in radians, and they have to end up being between 0 and 2 pi. So when I go through and I solve these, what I really want to do is I want to isolate my variable, just like I've done in Algebra 2, Algebra 1, and even prior to that. So really, when I go through and do that, I'm going to work from the outside in the attempt to isolate theta. So the first thing I can go through and do is subtract 1 from each side, because what that's going to give me is 2 times tangent of theta on the left and negative 1 on the right-hand side. Now from here, the next piece is to get rid of the 2. So I'm going to divide each side by 2. This is just like any other equation up to this point. Because now what I have is that tangent of theta equals negative 1/2. So looking at these, that's not a common value. It's not a tangent value of 30, of 45, 60, of 90, or of 0. So I can't really, at this point, if I didn't have a calculator, I wouldn't know how to move on. But since I do have a calculator, what I can do is I can take the tan inverse of each side to get theta by itself. So take tan inverse of tangent of theta and take tan inverse on the other side. So I have tan inverse of negative 1/2, because what that's going to do is tan inverse times tan reduces to 1, and I would be left with just theta equaling tan inverse of negative 1/2. So what I'm going to do, using my calculator, first off, I want to make sure I'm in radian mode, so toggle down to radian mode, and then I'm going to go through and go through and just plug this in. So I'm going to say second tan, go tan inverse, negative 1 divided by 2, and what that gives me is negative 0.463. So what we're going to do, we'll just say theta equals negative 0.46. We'll round to 2 decimal places here. Now, first off, my issue with this is it's not between 0 and 2 pi. So I need to change that. But what this is telling me is my reference angle is going to end up being 0.46. Now that's, oh, I can't even say this anymore. What it tells me is my reference angle is going to be 0.46. So I'm going to end up using that to solve for my other 2 answers. And we know there's going to end up being 2. So what we have to do first is figure out what 2 quadrants we're going to have them in. And we're looking at a negative tangent value here. We're saying tan of theta equals negative 1/2. So the 2 quadrants where we would have that would be the second quadrant and the fourth quadrant. Alright, everything is positive here, and tangent is positive in the third quadrant, so our tangent values would be negative in the second and the fourth quadrant. So what I have to really do from here, find out what my angle is going to be in the second quadrant, give me something here, and then find out what my angle is going to be in the fourth quadrant. What I do know for both of these is my reference angle. My reference angle here is 0.46. My reference angle here is also 0.46. So I have to go through and find both of these. To find this one, we're moving from pi backwards, 0.46. So all I'm going to really do is, since this angle measurement is pi, subtract 0.46 from it. This angle down here, since this is 360 degrees, and I'm moving, 2 pi radians, I'm moving backwards 0.46. I'll say 2 pi minus 0.46, and I just go into my calculator and I type both of those in. So I would say pi minus 0.46. That gives me 2.68. That would be one solution, and my other solution would be 2 pi subtracted by 0.46, which gives me 5.82. Alright, so 5.82. So those 2 angle measures in radians, 2.68 radians and 5.82 radians, give me a tangent value of negative 1/2, and ultimately satisfy this original equation that we had of 2 tangent of theta plus 1 equals 0. It would be those 2 angle measures.